Today I'll be presenting on Parkinson's disease. Anything that is a connection to class material is denoted with a purple star. First, we'll begin with some background. What is Parkinson's disease? Parkinson's is a progressive disease involving degeneration of dopaminergic neurons in the nigrostriatal pathway. The nigrostriatal pathway is primarily involved in motor control. This leads to a dopamine deficiency, and we've learned about dopamine in class. We know that dopamine is one of the many neurotransmitters that are responsible for making processes go in the brain. And the nigrostriatal pathway primarily loops through the basal ganglia, an area we've also learned about in class. It's a group of areas responsible for motor control and voluntary movement. Parkinson's is often identified by its motor symptoms, such as a stiff gait, rigidity, difficulty initiating voluntary movement, and slowed movement. However, Parkinson's also includes non-motor symptoms, and that is what I'm interested in exploring today. First, we'll take a look at memory. What effect does Parkinson's disease have on memory, and what are the underlying biological mechanisms of this effect? First, we see that people with Parkinson's have impaired explicit memory processes, even when they don't have dementia. And when we talk about explicit memory, we are talking about memory that you can talk about. So recognition, such as identifying things you've seen and you know, recall, remembering things without external cues, and prospective memory, like remembering to do planned things. It's of note that prospective memory is worse with event-cued plans than time-cued plans. This means that memory performance is worse when trying to remember to do something after something else has happened. This impairment has also been seen to worsen with increased disease severity or with task difficulty. Now, onto the biological causes of these memory effects. A study that used positron emission tomography, a type of research method that we learned about in class, found that there was decreased blood flow and glucose to the frontal lobe in Parkinsonian patients. This indicates that there's less activity in these areas, and this decrease in activity is linked to the memory defects that we see. The frontal lobe, as we've learned about in class, is responsible for storing memory and planning. It's also responsible for higher level thinking. We also see decreased blood flow to parts of the basal ganglia, which also plays a role in working memory, interestingly enough. We'll now take a look at how Parkinson's affects sleep. First, we know that Parkinson's leads to irregularities in circadian rhythm, meaning that the internal daily cycles that are used to regulate the body have been disrupted. This can lead to symptoms like insomnia, difficulty initiating sleep, and excessive daytime sleepiness. Disorders affecting REM sleep are also pretty common with Parkinson's, and we've learned about REM sleep in class. This usually manifests in the form of a lack of paralysis during REM sleep, which leads to acting out dreams. And it's been found that in some instances, sleep or sleep deprivation have been shown to improve motor symptoms in Parkinsonian patients. Now, as for why we see these effects on sleep in Parkinson's, we know that dopamine is essential for the regulation of our circadian rhythm, and the lack of dopamine seen with Parkinson's can dysregulate this rhythm. Particularly, it dysregulates melatonin, which is a hormone released by the pineal gland to signal that our body should get ready to sleep. With Parkinson's, we see that melatonin secretion rhythms are reduced and less frequent. This impairment is more pronounced for negative and dynamic emotions and less pronounced for positive and still emotions. This impairment does increase with progression of the disease, and it can cause difficulty with socialization. It makes it more difficult to read social cues, and it prevents the use of expression as context to vocal tone. We can see here a little graph from the study, and here we see that people with Parkinson's were less frequently capable of identifying which emotion is depicted. As for the biological reason for this, it's actually the fact that the basal ganglia is involved in emotion recognition. For example, fear is processed in the striatum and the insula. Parkinson's degenerates to these areas that are needed to process certain emotions, and especially the negative ones, which is why it's more pronounced with negative emotions. But it's also possible that other areas are affected since Parkinson's is not localized.